Operations with radical expressions. The two operations, math operations, that we're going to focus on today are adding and subtracting radicals. The only radicals we know are our square roots, so we're going to add and subtract square roots together, and we have some rules that we need to follow in order to do so. The first thing when we're adding and subtracting, we are going to simplify by adding and subtracting the coefficients. That's these numbers in front of our square roots. Okay. First of all, notice these are like radicals. They are both square root x. What's underneath the radical symbol has to be the same in order for us to add and subtract them. They are both an x, so I can add and subtract these square roots. Okay. Like the directions say on the top, it says you simply add and subtract the coefficients. So 3 plus 2 is 5. And then I just tack the root x along with. That's how this works. Okay, you just bring that square root, whatever that is. If it was a 2, it'd be root 2. If it was a 5, it'd be root 5. Okay, so we just add the numbers in front and bring that square root thing with. More examples here. I've got 6 root 5 plus 2 root 5s minus root 5. Well, that minus root 5 has a 1 in front of it. Those are all like radicals. Okay? They both have a 5 underneath that square root symbol. So I can add and subtract the things in front. Well, I have 6 plus 2 is 8 minus 1 is 7. And then I can bring that root 5 with. Simple as that. Okay, all I do is bring that root with. Okay, this second one is a little different. Okay, notice I've got a root 2 here, and I've got a root 2 here, but these other two are root 11. So I can only do the operations on the radicals that are like. Okay, well I had 7 root 2. I'm going to bring this minus 6 root 2 right next to that. I now have plus 8 root 11, if I copy my other terms, minus 4 root 11. I can now simplify by adding and subtracting the ones that are like. Well, for the first two, 7 minus 6 is 1 root 2. And then I have 8 root 11 minus 4 root 11 would be positive 4 root 11. So that's my solution. I only add and subtract things that are like, and then I can leave it. Last one. Okay. Well, the root 5s are the same. Then I have this root 7 at the end. Okay, that's not going to combine with anything. It doesn't have a like radical, so I'm just going to leave that one at the end. Okay, well, 3 minus 8 is negative 5, and I bring my root 5 with, and then I simply bring this thing down, minus 2 root 7. I can't combine it because they are not like radicals. So we're done. We leave it just like this. Sometimes we're going to have to simplify before we can add and subtract. Okay, I'm going to simplify these radicals. There's two problems here. We'll do the one on the left first. I need to simplify the square root of 18. It has a perfect square factor of 9. So I can break up root 18 as root 9 root 2. Notice I just brought that 3 in front along with us. I had plus 5 root 8, but I can break up root 8 as root 4 root 2. Next step is to take the perfect squares. So 3 times, well, the square root of 9 is 3. Okay, square root of 9 is 3. And I have a root 2 plus, bring everything else down, 5 times the square root of 4 is 2. And I bring the root 2 with. I can now multiply the constants. 3 times 3 is 9. Bring the root 2 with. Plus 5 times 2 is 10. Bring the root 2 with. Now if we see here, they are both root 2. So I can now add these radicals together. 9 plus 10 is 19 root 2, and that's my answer. Next one. Simplify root 20. Well, it has a perfect square factor of 4. So root 4, root 5, minus 5 times 45 has a perfect square factor of 9. So root 9, root 5. Now I can simplify those perfect squares. The square root of 4 is 2. And the square root of 9 is 3. I just brought everything else along for the ride. Multiplying my constants, I get 4 root 5 minus 15, and bring the root 5 with again. I now have like radicals. 4 minus 15 is negative 11, and bring my root 5 with. Last two examples are a little tougher. These will be the hardest ones you'll see. We're still doing the same things. We're going to simplify what we can for square roots, then add and subtract like radicals. First one, okay, there's two examples here. This one we'll bring over here. Okay, we'll separate these two. So I've got a 6 root 27. Root 27 has a perfect square factor of 9. So root 9, root 3. I can break up root 12 as root 4, root 3. And I can break up 75 as root 25, root 3. The square root of 9 is 3. The square root of 4 is 2. The square root of 25 is 5. That's the only thing I did on that step. Simplify the perfect squares. 6 times 3 is 18. Bring the root 3 with. 8 times 2 is 16. Bring the root 3 with. And 2 times 5 is 10. And bring the root 3 with. I have 3 like radicals. I can add and subtract those. So 18 minus 16 plus 10. If you do that on your calculator, 18 minus 16 is 2 plus 10 gives me 12, and I bring the root 3 with. Last example, 32 has a perfect square factor of 16. 16 times 2. So I broke up 32 as 16 and 2, plus 90 has a perfect square factor of 9. So 9 and 10. And 50 has a perfect square factor of 25. Simplifying my perfect squares. 3 times, well, root 16 is 4. Square root of 9 is 3. Square root of 25 is 5. Every time so far, I'm following my order of operations. Okay, I need to multiply these together first, then I can add and subtract. 3 times 4 is 12. Bring the root 2 down. 3 times 3, I gave away the answer. 3 times 3 is 9. Bring the root 10 down. 4 times 5 is 20. Bring the root 2 down. Okay, this time I've only got 2 like radicals. This thing and this thing both have root 2's. That tells me this plus 9 root 10 is just going to be added to the solution. 12 minus 20 is negative 8. Bring the root 2 with. and I have my solution. They are not like radicals, so I can't combine those. I am done.